they exiled a man for proving a number exists? Well, at least that's the legend. We're at 5th century BCE in ancient Greece, and a man called Hippasus just said that the number of square root 2 can't be written in the form every other number can be written in. More precisely, he said that there are no two numbers that, when divided one by the other, give us the exact ratio of square root 2. Sadly, he lived in a Pythagorean society, and these people were not amused. So instead of accepting his proof, they low-key exiled him. Others say they even killed him. For proving a number exists. Lucky for us, we don't live in that society anymore. What kind of number is square root of 2? Well, let's find out in this video. Hello internet, hello you, my name is Susan, and today is a pretty nice day. And fitting to the springy day we have, I'm gonna cook some asparagus with some tomato and potatoes. But first, let's get ready. Before we can start, we gotta wash these potatoes. So, numbers, is kind of the basis of math. Numbers are the first things we think about when we think about math. It's the first thing we see when we are introduced to our first math class in first grade. The thing kindergartners boast about when they're like 4 years old, telling everyone how far they can already count. And then pretty quickly we'll all have a moment when we start to hate numbers. I myself am not a fan of numbers, to be honest. Yeah, I like math, but I like the concepts, I like the ideas, and less the numbers itself. But that doesn't change the fact that they are an essential part of mathematics. And because mathematicians are humans, and humans like boxes, we also have boxes for numbers. It's not the 2 or 10 types of kind of boxes. Instead, we have what I would like to call the core, and then some outer layers. So let's start at the core, at the centrum, where we start in kindergarten. These numbers are called the natural numbers because they come pretty natural. It's not hard to imagine a priest or a human coming up for a word for 1, 2, 3, 4, and so on. And we still keep this system as the most basic one. These are called the natural numbers. They start at 1 and we go up to infinity. The next bigger system is also something we already learned about in primary school. But it appeals kind of pretty. I want to remark that the natural numbers don't include 0. 0 is only included once we take a step further up. So the natural numbers are embedded into the integer numbers. Integer numbers include all the natural numbers, including 0, and in addition, the negative numbers as well. So this time we start at minus infinity, include the 0, and go up into infinity. We make this distinction because the natural numbers have little to no structure, while the integer numbers already have a lot more structure that we're interested in. And we get even more structure if we allow for fractions. A fraction is when we, instead of having one number, have a numerator and a denominator. So 1/2 or 1/4. And for a long time, humans believed these numbers to be all the numbers that exist. However, today we know there's more to it. And we know that there are numbers that can't be represented by the division of 2 other numbers. These are called the irrational numbers. And it's easy to see that 1, 2, 3, 4 is still a part of the irrational numbers because we can just write 4 over 1. We could even write 8 over 2. So, but then what are these other numbers? Think, for example, of pi. Or if you've heard of the Euler number, think of E. I know you know pi, but have you ever thought of writing it in a other way than the symbol, or 3.1415 and so on? I'm sorry, there isn't. The decimal numbers behind the comma will just go on and on and on and on and into infinity. And there sadly is just no other way to write pi. And the same goes for E or the square root of 2. And as humans and as a society, we needed some time to adapt to the idea of a number with a never-ending tail. And to me personally, that seems fair, because what even is infinity? And if we add these kind of ugly but super important numbers to our overall number system that we've already established, then we get the rational numbers. And the numbers with an endless tail, these are specifically called the irrational numbers. So all in all, we have the natural numbers, 1, 2, 3, 4. These are embedded in the integer numbers, coming from minus infinity up to -2, -1, 0, 1, 2, and going into positive infinity. Next, we allow for numbers that have a comma, or that we can write as a division. 1/2, 1/3, 1/4, and so on. And lastly, we add the irrational numbers to get the real numbers. And these are the numbers we can't write as a fraction. So coming from the other side, we take the real numbers with all the numbers you can think of. Then go into the rational numbers, all the numbers you can basically represent with a pizza. Then we get the integer numbers, minus and plus. And in the center, they are the natural numbers. Just 1, 2, 3, 4, 5, and so on. However, there is one set of numbers that I haven't yet talked about. This is the set of the complex numbers. And I know complex already sounds complex, but don't worry, it's not that complicated. I want to take you back to primary school. Maybe you remember the number line where we have, say, 0 here, and then we go 1, 2, 3, 4, 5, 6, and so on. Okay, now we're going to do basically the same thing, but instead of just one number line, we're going to cross them, and we'll have 2. So when we keep 0 here, we have 1, 2, 3, 4, 5, 6, 7. And in this direction, we have a new number line. And this will also have the numbers 1, 2, 3, 4, 5. So far, so good. But then, how do I distinguish between the numbers on this line and the numbers on this line? Well, we give the lines 2 names. We will call the first one the real numbers, and the second one the imaginary numbers. And what about all this in here? Well, I'm glad you asked. So we basically use this as a coordinate system with real and imaginary lines. So then a number, for example, here will be at the position 1, 2, 3 on the real axis, and on the position 1, 2 on the imaginary axis. So our number that is placed here, we're going to use 2 real numbers to write 1 complex. Because just as in other coordinate systems, when we want to represent a number here, we will take 1, 2, 3 steps on the first line and 1, 2 steps on the second line. So this number here will be represented as 3 times the real number and 2 times the imaginary number. Real numbers, they don't have a label. These are just the numbers that we know. While imaginary numbers, they have a label, and this label is the letter I for imaginary. So the number here would be written as 3 plus 2 times I. And actually, every number in this field would be written as x times the real number plus y times the imaginary number. We often write zeta is a plus b times I. It looks good. Good, looks good, looks good. Okay, let's check. Come on. Yeah, seems good. Nice, I'm happy. And lastly, for the taste test. Thank you so much for coming by, and see you in the next video.